the more practice you can get with inequalities in your life, the more versatile you are as a mathematician. In fact, if you take the words differential equations and you rearrange the letters, it can spell inequalities and effort, which I think is one of the coolest things, because you do a lot of inequalities in differential equations. Maybe not at the undergraduate level, but definitely at the grad level. Okay, so one way of approaching this problem, in order to find a capital N, a threshold capital N, such that as soon as I cross that threshold, all of my little n's that are bigger than it will satisfy this inequality, is just to directly solve the inequality. But in this example, directly solving the inequality leads us to an inequality that's quadratic in n. Right? And so solving a quadratic inequality is not the friendliest thing in the world to do. We can do it here because we didn't know the value of m. We didn't know whether this might factor. And so we were stuck with using the quadratic formula. And then choosing just one branch of the solution, because that's the solution such that all the n's greater than or equal to it will still satisfy this inequality. So this is kind of messy. I mean, it works, and this is going to make the algebra really sweet when you go over here to finish your proof on the right-hand side, that Sn is greater than or equal to m. But I want to give you an option 2 on this. And this, again, sort of goes to what we were talking a little bit about last time, which is the how do we think in conceptual ways about inequalities. I like to think of it as how do we think about sort of how to take in an inequality and replace one quantity by a quantity that's bigger, or replace something by a quantity which is smaller. Here's the idea. It's certainly true that for the little n that we just solved for, that this inequality will end up being satisfied. But if, on the other hand, I can find an easier quantity to work with over here, which is guaranteed to be, let me say, greater than or equal to here. If I can find a quantity which is greater than or equal to n squared over n minus 1, then if it's always greater than or equal to n squared over n minus 1, then in particular, it will also be greater than or equal to m when this inequality is satisfied. So I have a fraction, n squared over n minus 1. How can I replace this fraction with a related fraction which is larger? I can either make the numerator larger, so I could do n squared plus 1, or n squared plus n, or something. I could make the numerator larger, or I could make the denominator, either make the numerator larger, or I can make the denominator smaller. Right? Denominator is a bizarre world. So if I replace the denominator by something which is smaller, let's say if I replace it with n minus 2 instead of n minus 1, then I know that that quantity is going to be less, or sorry, that fraction is going to be greater because the denominator is lesser, right? So what I'd like is to do one or the other of those things. But when I do, I want to make it so that I get an inequality that's easier to solve somehow, right? So let me leave the n squared upstairs alone. And let me try and do something with the n minus 1 downstairs. Because of that two-term denominator, we can't actually do any algebra with this. So, and I'm going to leave you with this to kind of chew on. Can we show that 1/2 n is in fact greater than or equal, is less than or equal to n minus 1? Is 1/2 n less than or equal to n minus 1? I don't think it's true for all n, but it certainly is true for all n past a certain point, which we can find just by solving this subordinate inequality here. So this would be subtract n from both sides. Now divide by negative 1/2. And so for all n that are greater than or equal to 2, this inequality in brown here is true. But this thing on the left is now much easier to work with. N squared over 1/2 n is otherwise known as just 2n. And what's great about that is that now I can solve my inequality as just the inequality 2n is greater than or equal to m. And solving that for n is a whole lot easier. 2n is greater than or equal to m. So n is greater than or equal to m over 2. So what this all means is that we can go forward with just two pieces of information about n. We want, on the one hand, n to be greater than or equal to m over 2, so that 2n is greater than m, right? So that this quantity is greater than m. But we also need n to be greater than or equal to 2 so that this part of the inequality is satisfied. So the way we're going to define our capital N now is a little bit different. We're going to define our capital N in such a way that we know that it's greater than or equal to both of these quantities. And in order to be greater than or equal to both of those quantities, let's take n to be the maximum of those two quantities. And again, since m over 2 is not necessarily a whole number, I'm going to round it up using the ceiling function. So that's a way of circumventing the algebra a little bit that was involved in solving the inequality in the middle, just by using a little inequality hocus pocus.